So this is the helmet that we designed for the multidisciplinary MH project, APH 1803. So coming to the components of this helmet, we have a Kinect which has both the 3D depth sensing camera as well as the RGB camera. This system is used for the indoor navigation, indoor obstacle avoidance, and then we have the sonar sensors that are placed. Three sensors are placed in the periphery of the helmets, and this system, these sonar sensors are used for the outdoor obstacle avoidance. And then we have the switches, three switches that are used for navigating between different modes of operation. And then we have the Raspberry Pi 3, that is the controller that is used for controlling all the signals that comes from the Kinect, sonar sensors and the switches. And then we have the sound card that which you can see in the bottom. The sound card is used for generating the tones and manipulating the frequencies and intensity of the sound signals in case of the auditory feedback system. And then we have the microphone that is used for the mail notification system, and then we have the speakers that we have connected for the voice output, but this will be replaced by the earphones in the original system. Just for the demo purpose we have used a speaker. Okay, coming to the indoor obstacle avoidance system with the auditory feedback. So we have two set of speakers that is used for giving the audio feedback to the user. So similar to the vibratory feedback system, in the auditory feedback system, we are using the Kinect depth data to be able to find the location of the obstacle. So the auditory feedback system is more expressive than the vibratory feedback system, because we have the height axis mapped to the audio signal as well. But in case of the vibration system, we only had the distance map. So in case of this system, we have the height mapped to the frequency. So in case the height of the obstacle increases, you will get a higher frequency tone. See, as the height of the obstacle increases, the frequency increases. And similarly, if I move back and forth, you can see the intensity of the sound changes. So in case the obstacle is very near, you'll get a very higher intense tone, and if it goes quite far away, then the intensity of the audio signal is very low. So we have designed a small sound card that is used for generating these tones, and the sound card also manipulates the height and frequency based on the control signals that are generated from the Raspberry Pi. So this is how the user will be able to perceive the obstacles using the auditory feedback system. So coming into the computer vision systems that are integrated into this helmet, there are three systems: the object recognition system, the text recognition system, and the currency detection system. So these three systems use the RGB camera of the Kinect sensor. So I'm going to show a demo of the currency detection system. So I'm going to switch it on to the currency detection mode. So
mode change to currency detection.
So as soon as I change my switch position to the currency detection mode, you will get a voice command telling that you have changed to the currency detection system. So I just need to show the $20 bill in front of the Kinect sensor, and it will automatically detect the $20.
$20. $20.
And you will get a voice command telling $20. And the same is the case for the $5. And it could be extended to more different currencies from different countries.
For the next computer vision system, we developed a text recognition system to help the blind to read blocks of text while they're navigating. So right now the system is optimized to find room numbers. For example, I have an EA302 room which is printed out. So let's see whether the system finds it. So now I'm going into the text recognition mode.
Mode change to text recognition. EA302 room found.
So as you can see, the
EA302 room found.
the system has currently identified the room number.
So coming to the object recognition system of this helmet, so as every person have their personal objects, something like a bottle, purses, keychains, and their umbrellas. So for normal people, it will be easy for them to keep track of the things where they are. In case they keep it on the table or the floor, they can easily find it out. But in case of the blind people, it's going to be quite difficult. So what we made, we designed a system that helps the blind user, to be able to detect their personal belongings. So as a proof of concept, we have just designed a cascade classifier which will be able to detect the bottles. So this is how the system works. So in case we bring a bottle in front of the RGB camera, you will get a voice command.
Bottle found. Bottle found. Bottle found. Bottle found. Bottle found. Bottle found.
So in case
Bottle
you
found.
remove it out of the frame and don't get anything. So that's how the system works. So coming to the mail notification system that is implemented to this helmet, this allows the blind person to be able to send and receive emails by using the helmet itself. So the Google Gmail API is used for accessing the visually impaired's Gmail, and it will see if the user has any 100 messages, and in case there is some 100 messages, then a voice command will be generated telling that you have so and so message from so and so person. So apart from this, we have a system that will allow the user to send voice messages by using this microphone. So as soon as you press one button here, it will change into message sending mode, and you can say a message into the microphone, and it will be transmitted to the person who sent the message.
Okay, so now I'm going to send a mail to antonyalbertraj@gmail.com, which is the mail that has been configured in the helmet. So my message is, can we meet tomorrow to discuss about the project? So I'm sending the mail.
You have an email from vimal.chandran@mail.utoronto.car. The message is, can we meet tomorrow to discuss about the project?
So coming on to the mail sending feature of this helmet, the helmet has an inbuilt microphone that allows the user to send voice messages to the person who sent an email. So before getting into the email sending mode, you need to press a button. Once you press a button, you will get a voice command telling that start recording. When it tells start recording, you can give your voice message to this microphone.
Please tell your message.
Yeah, sure. We can meet tomorrow at the room number EA302, and let's discuss about the project and its progress.
So it can be seen that there is 100 message, and here's what it says.
Yeah, sure. We can meet tomorrow at the room number EA302, and let's discuss about the project